Okay. Hello, everyone. Good evening, everyone. Am I audible?
Yes, audible.
So, this week like in this session we will discuss questions related to the week 8 content, in which we solve how to develop or generate the differential equation for the multi-degree of freedom system. So we will solve around 5 to 6 problems. If time allows, we can go more than this problem also. So let me share my screen first so that we can have is my screen is visible.
Yeah, visible.
Okay, thank you. So let us start. So we have a first question in which we have a three mass and four spring. It is a combination of the spring mass system. So we have one is this system, then this one, and then this one. So each one has had degree of freedom of x1. Each mass of the block has the degree of freedom as three. So because we have three in the direction it is allowed, like it can go in the three-way vibration in x1, x2, or x3. So we have the three degree of freedom system. So we have to develop a equation of motion for this system, like governing differential equation of the system. So do you have any idea how do we develop this equation? Okay, if not, then we will go one by one. So to develop a like the differential equation of the system, like here we also use the equilibrium equilibrium of the forces. So as we have discussed in the single degree of freedom system also, like we should follow that which one we should go with the uh, first we need to draw a free body diagram of the system, like how my like the forces are applying on that particular mass block or on a structure. So we will go one by one. So first we will draw the free body diagram of the system. So let us take, like we call it as a mass block 1, 2, and 3. Okay, so let us draw a free body diagram for this mass block m. Okay, so there will be a force mg is applying downward. Okay, so then we have the reaction force n, which is equal to the mg. So that's okay. And if we are applying a movement in the x direction, we are giving the deflection. Okay, so how much force will be developed? One is that inertial force, which would be the m x1 double dot. Inertial force would be the resisting force is there, and we have the spring force, this one. Due to this, we have how much? K time x1 is that. Up to this there is no problem. Now we have the another spring is there at that place. Okay, so now if I am applying x1, x1 is giving this is moving, then x2 is there. Okay, if my what happen if my x1 is greater than x2? If my x1 is equal to x2, is there any deformation in the spring? Is there any force will develop in the spring if my x1 and x2 are equal? No. So to develop a force in the spring, our x1 should be greater than x2, or either my x1 should be less than x2. That would be negative side, obviously. Okay. So if my x1 is greater than x2, so how much force would we apply it there? Like if this applying, like let us suppose I have a spring here, and at this point I have x1 before x1, at this point I have x2. So total deformation would be the, because x1 is greater than x2, so that would be x1 minus x2. So how much force would be registered by this? That would be the 2k time x1 minus x2. Is it okay? Okay. Then we need to write the free body diagram for the second block also. So for the second block, we can call it as first. Then for second, we have again m, that would be the n, that would be mg, and we are applying x to it here. Okay. So in this case, one force is what? Inertial force would be the same, because my mass would be feeling the same force. That would be the m x2 double dot, and the spring force is what? Spring force is what? Whatever will be apply it here, that would be the same at here. Only the sign would be the in the, because if I have this force is at this direction, then the opposite would be the this. So here my spring force would be the 2k x1 minus x2, or either I can apply this as this one. Then we need to write it 2k x2 minus x1. If we take x2 is greater than x1, then my case would be this one. If my x1 is greater than x2, then my case would be this one. So in this case, any doubt? Someone has any doubt? Okay. If not, then I have the another spring at this spring also. So for this, I have what is that? X2 is greater than x3. If that, my force would be applied k into x2 minus x3, this way. Okay. Now for the third block, same mass is there, mg is applied downward, and the reaction force is n. So that would be same. If I am applying x3 displacement to that, so how much that would be m time x3 double dot. Okay. And how much? Similarly same kind of force, but in the opposite direction. So that would be the this one, k into x2 minus x3. Or you can write it as a, if my x3 is greater than x2, then it would be like that, k into x3 minus x2. Okay. And then I have one more spring it here, so that would be simply k time x3. Is there any doubt in the free body diagram? Any doubt in the free body diagram? If you don't have any doubt, then it will become very easy. So now we can write the equation for all the three blocks. Okay. So now you can you write this equation for this system, all three system, and combine it into the like a matrix form. Write it. So now we will write the equation. Okay, so for first block, or we can say mass, we have the equation is like that: mx double dot 1 plus kx1 plus 2k into x1 minus x2 is equal to 0. For this block, mx2 double dot minus 2k x1 minus x2 plus k into x2 minus x3 is equal to 0. For this block, mx3 double dot minus k time x2 minus x3 plus k into x3 is equal to double dot. So is it okay up to this? Do you have any like doubt in this? Like how do I write the equation? Anyone? If not, then we will what do we do simplification of these equations so that we can write it into the matrix form. Okay. So for the first block, what the equation do we have? Mx1 double dot plus kx1 plus 2k x1 minus x2, 2k x1 minus x2. So this I can write also, like let me write it like the mx double dot kx1 plus 2k x1 minus 2k x2 is equal to 0. So that become as a mx1 double dot plus this one would be 3k time x1 minus 2k time x2. This is this would be the equation number 1. Okay. Now write the for the second block, or we can say mass. What is that equation? mx2 double dot minus 2k x1 minus x2 plus k into x2 minus x3 is equal to 0. So we need to simplification of this. So that can be mx2 double dot minus 2k x1 plus 2k x2 plus k x2 minus k x3. Okay. So that would be the mx2 double dot. Now the x1 term is only one there, 2k x1. X2 are there two term, that will be 3k plus x2, and only one term for the x3. Okay. So this is the second equation. Okay. Now we need to write the third equation for the third block. Okay. So in this we have the mx3 double dot mx3 double dot minus k into x2 minus x3 plus kx3. So if I will simplify this, mx3 double dot minus kx2 plus kx3 plus kx3 is equal to 0. So that would be mx3 double dot, and it would be minus kx2 plus 2k x3. Okay. So this is the third equation. Now we can if we need to solve this system, finding out the natural frequencies, like the all three frequencies and the mode shape, then we need to write, to solve this we need to write those equations into the matrix form. So equations in the matrix form. So I can write like this: x1 double dot, x2 double dot, x3 double dot, plus for k it would be x1, x2, x3. So what is this? M 0 0 0 M 0 0 0 M. So for this you can write what is the coefficient of the first row: 3k minus 2k is 0. So that would be 3k minus 2k 0. For this, what is minus 2k, 3k minus k? So that is the minus 2k, 3k minus k. And for this, 0 minus k, 2k. So this is my final answer. Any doubt? Anyone in this question?
In stiffness matrix, we can always say it is symmetric, right?
Yes, that should be symmetric. If yeah, that would be symmetric. In some cases, it might not be symmetric, but most of the time it would be symmetric.
Okay, actually, this question has can be solved like it's like a three-story building. When you apply a lateral force on first mass,
Yes,
and we can
that
solve
that
this.
way that way we can also solve.
Yes, yes, yes. In that case, we can directly say like the coefficient first one is positive nature, but remaining are negative. We can say like that.
I think you are talking about like that. Like let us suppose I have a two-story like that, and I am applying a unit displacement to
Yes, yes,
that kind of matter. Then I am applying this one direction force. Then my
yes.
force would be the some k1 time x1. Then it would be also k1 k2 time x1. Some sort of like that you are talking about that.
Yeah, yes. If suppose in K11 is if K11 is positive,
Yes,
can I say K21, K31 could be negative, right?
it could be negative, but not always. That depend on problem to problem. In some case, like most of the time, your matrix would be symmetric, but
Yes.
or in that case, what happen? Our mass matrix is not coupled; it is uncoupled. Sometimes your mass matrix is also coupling. Like most of the time, you are seeing like you have the always these things are zero. Okay, but in
Oh,
some cases, it is not necessary that these things would be zero.
yes, yes. That is okay. Okay, okay.
So, more in this course, you will be face all the problems related to the symmetric matrix.
Yes, yes.
So that's
Okay. Thank you.
okay. So let's move to the another question. So this question also a same kind of questions, but a different nature. Like in this also we have the 3 degree of freedom system. I think question is visible to you. Like we have the 1 degree of freedom theta for this one. Okay, 1 degree of freedom for this one is the x1, this one is the x2. So we have the 3 degree of freedom system in this case also, and we have applied a force Ft at the middle of the bar so that we can find out the differential equation of the system in terms of the x1, x2, and theta. Initially, those were in the all the translational. In this one is the rotational, and the two are the translational. So, can you do it? Like, can you give us some time for thinking about how it will work? Like, at least make some free body diagram. So, if you are facing any issue with that, then when I solve these questions, you will be able to do that. So give a try.
Here, X1 and X2 are the same location, right?
Yes, x1 is at the 2m, x2 is the m.
Okay.
Anyone has any doubt in the session, chat session? No doubt? Then that's okay. Let us discuss this one. Is anyone with the free body diagram? So, uh, first we will make the free body diagram for the bar, or we can say the road or the B, whatever it is. So, okay, and if it will deflect, I am giving a theta rotation. Okay, then how much this one? That would be the L theta, and that at the center, that would be the L theta by 2. Okay, so if this will go downward, then the resisting force of the spring force, that would be the upward, Fs, that would be K into L theta. Okay, and then we have the F1 at that point, so that would be obviously that would be being in that same direction, F1t, or you can say sometime F1 also directly. And we have one more spring is attached to here. So at the middle, When I give the L theta is the displacement, how much at the middle that will be the deflection is the L theta by 2. So that spring will deflect like at the top I am giving L theta by 2, and at the bottom it is like x2. So it will deflect when my L theta by 2 minus x2 would be greater than 0. Okay, so that my spring force, this one would be the k time L theta by 2 minus x2. Okay, so that force would be applying it here, k time.
I couldn't get. Can you please explain once? There, L theta by 2 minus x2.
My when my spring will deform, there is some relative displacement. If my L theta, like if my L theta by 2 equal to x2, is my spring will deform? Not the x2, sorry, here we have the x1. Okay, so don't be confused.
Yeah, okay, it's okay.
Okay, because I was taken that as x2. Now is it okay, everyone?
Yes.
Okay, so this is the for the like the beam. Now same kind of let that we can write the free body diagram for the, like this one is the roll. Now make the for the second, for the globe. So for this, and in that case bar also we have the bar, mass as a m bar, rigid bar. So that inertial force I theta double dot will always be there. Okay, so in this it has the 2m. Okay, so that is the same in the, in that direction, k into L theta by 2 minus x1, or you can write in this direction with that k into x1 minus L theta by 2. Okay, this way. And in the bottom, then how much, how this force will be applied, that will be 2k into x1 minus x2. Okay, x1 minus x2, or it either is this force will apply downward if my force 2k would be x2 minus x1. Okay, and then the inertial force, that would be the upward direction, 2m 2m x1 double dot. For third one, I have the again mass, that force, that would be the, in that direction, 2k x1 minus x2. That force would be the m time x3 double dot, and there is nothing is right, that would be the f2 is there, f2 is also there. So is there any doubt in the all the three free body diagrams? Anyone, if you have drawn the free body diagram, you can now check your, like, is it the same whatever we have drawn, or is any difference in that? Because after making the free body diagram, you will be having only the one thing, like you need to write the equation doing the forcing balance. There is nothing to do that.
Is there any gravitational uh, force in the
Gravitational you can take, but when you initially if you solve this equation, like if you have read in the first week content, I think, that if you have a mass spring mass system and then mass, then how will you write it? Like there is total displacement at this will be the u static plus some sort of deflection x in this. Is it okay?
Okay, okay,
So then you write the equation m x double dot plus g, static force.
okay.
Okay,
Here we are considering from equilibrium positions only. We
yes,
are
yes, yes,
thinking these. Okay, okay.
yes.
Thank you.
So if you will consider the equilibrium position, that would be 0. So that's how those things work. So now we can write the equation for this. So let us write the one by one equation for the equations. First we have the for a bar. So we have, if we take the moment about the hinge point, we can call it as a, in this equation we don't give any, we can write it as a O. So if we take the moment about the O, so what is this? I theta double dot plus k l theta time l plus k l theta by 2 minus x1 time l by 2 equal to f1 t time l by 2. Okay, so what would be the I for this one, for the road about the end we will take the, what is the inertial, anyone, about the end of the bar?
ml square by 9.
No, how it would be ml square by 9?
ml square by 3, no?
Yes, that should be
Sorry,
ml
sorry.
square by 3.
Oh,
ml square by 3.
Yes, yes. So now let us put the equation into this. Ml square by 3 theta double dot plus kl square theta plus this kl by 2 theta minus k time x1, sorry, that would be l square by kl square by 4 into theta, and that will be the k l by 2 into x1 is equal to f1 t into l by 2. So that become ml square by 3 theta double dot plus 5 kl square by 4 into theta minus kl by 2 into x1 is equal to f1 t into l by 2. So that is the one equation. Now the second equation we can write for the block. So that would be the summation of f of y is equal to 0. So that would be the 2m x1 2m x1 double dot minus k l theta by 2 minus k l theta by 2 minus x1 plus 2k x1 minus x2 plus 2k x1 minus x2 is equal to 0. Okay, so we can write this, like simplify this equation as a 2m x1 double dot minus kl by 2 theta plus k x1 plus 2k x1 minus 2k x2 is equal to 0. So 2m x1 double dot minus kl by 2 theta plus 3k x1 minus 2 x2, okay, is equal to 0. So this becomes my equation 3. Okay, now for the third block, that would be the mx3 double dot minus 2k x1 minus x2 x1 minus x2 is equal to f2.
Actually, this is mx2 double double.
Oh, mx2 double dot. So if we simplify this, that would be mx2 double dot minus 2kx1 plus 2kx2 is equal to f2t. Okay, so that is 1, that would be 2, and that is a 3. Now we can combine these equation into metric form so that it can be easily solved. So combine all the equations. So that would be the first one is our theta double dot x1 double dot x2 double dot plus k matrix. It would be the theta x1 x2. It would be whatever that we would be having. I will add it. So in this mass matrix we have the ml square by 3, so that we can like ml square by 3, 0, 0, 0, 0. Another is the 2m, 0, that is the m. Okay, for this one 5kl square by 4, 5kl square by 4 minus kl by 2, 0. In this minus kl by 2, 3k minus 2k, this it would be minus 2k, sorry it would be 0, minus 2k and 2k. And the forces are, in the first one that was the f1l by 2, 0, and that is the f2t. Is it okay? Any doubt? This is the equation. Further you can solve little bit if you want simplify that l, you can divide it somewhere in the equation. That's how you can do. So is there any doubt in this question? Anyone? Any doubt? If not, let us move to the another question. Please go through this question by one. Then we will develop the equation for this. If are you able to understand this question, please develop a equation of motion of the system, like it would be a 2 by 2 matrix, and then solve the for the part B whatever they said, like for k and m is given to us. So using that we can find out the frequency and the mode shape whatever they are asking. So first understand the question. Did you able to? Are you able to understand the question? Like we have a sphere of mass m, it's attached to end at the end of cantilever beam that is fixed to a carriage of mass 2m. Okay, and as shown in the figure below, the generalized coordinate of the system are the absolute displacement x1 and x2 of the carriage sphere. So the respectively determine the following the equation of the motion system, and then the further we need to do simplification. So that I can simplify this system, can I simplify this system as like that? Like a mass m it attached it here, then a column, then a mass 2m, and then a column. In that it is x2, it is x1. This has a stiffness of k, and this is a stiffness of the, how much stiffness it would be? Anyone? If I will convert this, how much stiffness of this column would have?
4K.
Yeah, that would be 4k. So now there is nothing in this question. So let us solve this question. So this you can solve this by making the free body diagram, as well as when you solve like that, you are giving an initial displacement to develop the equation of motion like that. So let me just first make the free body diagram of that part. First we will make that part, then we will make that part. Any of the part you can make. Okay. So first let us suppose the mass m, which we are giving a x2 displacement. So that would be the first mx2 double dot. Okay, and then another is the force, that would be how much, that would be negative in this the resisting, when it will be k time x2 minus x1. Okay, so that is the one thing. For the second, this was the for the first. For the second, how much, if 2m mass is there, and if we are applying a x1 displacement, so that would be the 2m time x1 double dot, and that displacement, that would be the, in that direction would be how much. So from the above, that was the k into x2 minus x1, so that would be in this direction, k x2 minus x1, one is that, and we have the in the bottom we have the how much, 4k, so that would be the 4k
4KX1.
time x1. So now you can write the equation of motion, summation of f of x is equal to 0. So that equation would become as a mx2 double dot plus k x2 minus x1 is equal to 0, or we can write it as a mx2 double dot minus k into x1 plus k into x2, this one. And for the second one, f of x is equal to 0, so that will be a 2m x1 double dot plus 4k x1 minus k into x2 minus x1 is equal to 0. So I will simplify this, 2m x1 double dot, so that will be the 4k x1, and then there is one more from here, so that becomes a 5k x1 minus k x2 is equal to 0. Okay, that is equation 2, and that is equation 1. Okay, so write this into the matrix form. So I will write it 2m 0 0 m x1 x2 plus 5k minus k minus k k x1 x2 is equal to 0. So this is our final equation. Okay, so now in this question they have given to us what, like they have given us m is equal to 35 kg and the k is the 35 kilonewton meter. So you have given the part b, m is equal to 35 kg and k is given you as a 35 kilonewton per meter. So can you calculate the eigenvalue and vector?
Sir, above equation that would be x1 double dot and x2 double dot in matrix.
Yes, yes, that should be. Thank you. That would be x1 and x2. So now you have the equation, you have the mass, you have the stiffness. Can you give me the mode shape and the mode shape vector, eigenvalue and eigenvector? Give a try. Anyone with the answer? Anyone? Let us discuss if you haven't find the answer. So to find out the eigenvalue and eigenvector, what I need to do, k minus lambda m is equal to 0, the characteristic equation. So I can write my equation that is 5k minus lambda time 2m minus k minus lambda time m, okay, is equal to 0. So if I will take, let us suppose I am taking m outside, like I am replacing, I can do this. Let me tell you, you can tell me, like if I am writing this 5 minus 2 lambda dash minus k minus 1 minus 1 1 minus lambda dash is equal to 0, and where lambda dash is equal to lambda time k by m. Can I write this? Anyone? So what happened with this, if I will replace this, like if I have given the different value of k and m, then I do not need to solve the equation one by one. I have the final equation, then I can solve it. So now with that I can solve this. I will take the determinant of this equation, so that will 5 minus 2 lambda dash 1 minus lambda dash minus 1 is equal to 0. So the final equation would be the 2 lambda dash square minus 7 lambda dash square lambda dash plus 4 is equal to 0. So if I will solve this, anyone, if I will solve this, I am getting lambda 1 dash is equal to 0.719 and lambda 2 dash is equal to 2.78. Okay, I think there is a mistake. That would be the lambda is equal to lambda dash into k by m. So that lambda dash would be the lambda into m by k. Either k, you can write this or this one. Is it okay? So now I can find out the lambda 1. So lambda 1 would be the lambda 1 dash times the k by m. So that would be the 0.719 time k, how much, 35 into 10 raised to power 3 divided by 35. So my lambda 1 would be coming out to be 719 lambda 1. For lambda 2, that would be lambda 2 dash time k by m. So that would be the 2.78 into 35 into 10 raised to power 3 divided by 35. So the lambda 2 is coming out to be 2780. Okay. So from this, can you give me the omega 1 and omega 2? So that would be the 719. So that will give me the 26.8 radian per second, and how much I am getting? I am getting 52.75 radian per second. So these are my model frequencies, omega 1 and omega 2. So now can you find the eigenvector? Anyone? Any doubt up to this? If not, then find out the eigenvector. So for lambda 1 dash is equal to 0.719, that will be the 5 minus 2 into 0.719 minus 1 minus 1, 1 minus 0.719 into x11 x21. So if you will solve this, you will get a equation of 3.56 minus 1 minus 1.28 x11 x21 is equal to 0 0. So you will get a equation minus x11 plus 0.281 into x21 is equal to 0. If, as in the question, like I have to normalize with respect to degree of freedom, what, 2 or 1, corresponding to 1. So if you do with the corresponding to 1, if you do corresponding degree of freedom 1, or let us first discuss this. Let us keeping the x21 is 1, so our x11 directly comes to be 0.281. Normalize you can do later also. So lambda 2 dash is how much? Is 2.78. So if you do that, that would be 5 minus 2 into 2.78 minus 1 minus 1, 1 minus 2.78 into x12 x22. Okay, so if you will do that, you will be getting 0.56 minus 1 minus 1.178 into x12 x22 is equal to 0 0. So you will get it minus x12 minus 0.178 x22 is equal to 0. So let us consider x12 as a 1 1, x22 as a 1. So my x12 would be the minus 0.178. So my modes will be, in the first mode I have the 0.28 1. In the second mode I have 0.178 and 1. These are normalized with the 2. So if you want to normalize with the 1, divide with the 0.28 and 0.178 up and down, so you will get the normalization with the eigenvector. Is there any doubt in this? Anyone? Anyone has any doubt in this? To finding out the mode shape or not? If not, let us move to the next question. So that is a bigger question that will take time. So we have a figure shown in the uniform slab supported on the four columns rigidly attached to the slab and the clamp at the base. The slab has a total mass m and it rigid in the plane and out of plane. Each column is of circular cross section and its second moment of inertia of the cross section about any directional axis is noted as given to x I2 I and which is same for the both the direction. With the degree of freedom selected as a ux, uy and u theta at the center of the slab. using the influence coefficient. Formulate, now we need to use the influence coefficient. Formulate the mass and stiffness matrix in terms of the m and the lateral stiffness k, which is given to us at 12 EI by h cube of a smaller column, which has the height h. Okay, so and the formulate the equation of the motion from the ground uh, in x direction, y direction, and the direction dB uh, in the diagonal direction. So the first part is what, in that one you have to do the deflection in this ux, then uy, and then a u theta. So you will be having 3 by 3 matrix is that ux, uy, u theta plus some k, then same for the ux, uy, u theta, and then some forces, something like that. You need to do that so that we can start like formulating the stiffness matrix, and then we will formulate the mass matrix as well. So let's, so first I am applying the displacement in the x direction. So I can find out the stiffness. So it has the I. How much stiffness it would have? Can you give me the column's stiffness? That would be the 12 EI by h cube. This is also k is equal to 12 EI by h cube. For this one, 24 EI by h cube, and for the this one also 24 EI by h cube. Okay, so I can write it as stiffness for this one is the k, this one is for k, this one is for 2k, and this one is for 2k. Is it okay? So now let us apply the displacement in the x direction ux. Okay, so how much force will be the applying it here? At this it would be k, at this it would be k, at this it would be 2k, at this it would be 2k. Okay, and in the middle we have the kxx, kyy, and kyx, and k theta x due to x in the rotation. So how much? First, for the kxx, that would be the summation of all the springs. So that would be the k plus 2k plus 2k. So that becomes as a 6k. To find out the kyx, that would be 0 because there is nothing in the y direction, nothing. Then we need to find out the k theta x. So for the k theta x, what is that? That would also be 0 or not? It would not be 0. It would be like distance is how much? B by 2. So that would be the 2k into b by 2 plus k into b by 2. That would also I think 0 minus 2k into b by 2 k into b by 2. So if you solve this, that would be 0. Any doubt in this? Anyone? How I find out the kxx, kyx, k theta x? Anyone has any doubt? Because if you have any doubt in the initial, then it will become a later like problematic. No? Then okay. Yes, anyone has any doubt? Komal, can you can ask if you have any doubt. You have raise your hand. Komal, do you have any doubt? You raise your hand. If not, let us go to the in the y direction. This is in the x direction. Now we will go for the y direction. Same thing for the y direction, you can do yourself. So in the y direction, if I am applying uy is equal to 1, so it's that kyy, kyx, kxy, and then it would be the k theta y. So how much it would be? K 2k, k 2k. So the kyy would be summation of this k 2k, k 2k, 6k, and kxy would be 0, and how much is the k theta y? That would be 2k into v by 2 minus, because it is in the clockwise anti-clockwise, so it would be in the clockwise, minus 2k into b by 2 minus 2k into b by 2, and then it would be the minus k into b by 2 minus plus k into b by 2. So how much it will remain? So k theta y would remain as a minus kb. Okay, now apply it into the theta right direction. So for theta, if you give a theta is equal to 1, okay, then this force would be the apply in this direction, k kb by 2, because we have discussed that in the last session also. Kb by 2, kb by 2, that is 2 kb by 2, and that would be the 2 kb by 2. Okay, and in the y direction it would be also same, because the slab has the same size, that is kb by 2, kb by 2, 2 kb by 2, and 2 kb by 2. Okay, now if you do the summation of f of x, then you have the things k theta theta, kx theta, ky theta. Okay, so summation of f of x is equal to 0. So if you do the into the f of x direction, so that would be the 0, kx theta would be 0, because that would be the how much, you can say this 2 kb by 2, kb by 2 minus 2 kb by 2 minus kb by 2, so that will cancel out each other. Okay, similarly ky theta is also 0. Not, I think not. For ky theta, you have how much? Ky theta, you have the plus minus 2 kb by 2 minus 2 kb by 2 plus kb by 2 kb by 2 is equal to 0. So if you will solve this, you will find it will be coming out to be kb. Then k theta, you need to take the moment about this. So when you take the moment about this, you will find 4 times kb by theta into b by 2 plus 4 times 2 kb by 2 into b by 2. And if you will simplify, you will find out 3 kb square. Okay. So then your stiffness matrix k would become as a 6k00, 6k00. In this it will become 0, 6k minus kb, and in this it will come down to 0 minus kb, 3 kb square. So this is your stiffness matrix.
While calculating k, y, theta,
Yes,
we are considering here minus 2 kb by 2 minus 2 kb by 2. That
yes,
is negative sign. For that, plus kb by 2 plus kb by 2, we are taking positive sign, right?
yes.
Then how can we take like that? We can take
because
reverse.
because you can see like the kb by 2 in that direction, that is
Okay,
in the upward direction, 2 kb by 2, and the kb by 2 in the downward direction.
okay. Then what is the significance of this minus and plus here? Uh, can we write reverse order?
Oh, that you are asking.
Yes, yes, yes.
That depend on your how the rotation you are applying, actually. So that,
Then the stiffness matrix will be different, right? Okay.
because that is a resisting force always.
Ah, yes, yes, yes. Understood, understood.
Understood?
But you said always here k theta direction we have applied, right? In theta direction, that is a 3 kb square is a positive nature.
Yes.
Just I have asked in the first question only. In the first question, what I have asked is when we applied in theta direction, that will be positive. Remaining all are negative or zero. Can we say like that?
Which one again ask me what you are saying? If you are
Yes,
applying k theta,
yes, yes. K theta is positive, right? 3 kb square.
yes,
Can I say the remaining two are negative or maybe zero?
remaining two are which one? Ky theta and kx theta.
Yes, yes. I'm asking. Yes.
No, here because the coupling is there, rotation. In the translational, you can have the same kind of behavior, but in the rotational, that is not necessary. That would be zero.
Can you say this upward is negative, downward is positive you are taking? Can you please explain how you are taking this signs?
Okay, let me explain. So in the first one, we are applying ux in this direction. Okay, so our kxx would be in this direction.
Okay,
Okay, and then the uy in this direction, then the your kyy into opposite direction. All okay,
okay,
and if you apply k theta x in this direction, then you can take the into the reverse direction. Okay, like if you are like in the applying direction is that k theta x, like u theta you are applying in this direction. Let me, if you are applying u theta like that,
okay,
then your rotational will be in the opposite, that is
okay,
k
okay.
theta. So in the first one there is no problem. Okay, so
Yes.
in the second one, if you will go, if you will check this one, then I think maybe there is some sign confusion always, maybe there. So we apply this direction, so we have the kyy in this direction, that is okay, and kxy would be in this direction, okay, and then your k theta, if I will apply in this direction, then it should be different, then it would be plus kb,
Yes, yes.
then it would be plus kb, okay, okay.
Okay.
If that is the k theta y, then our this one is the plus plus, and then it would become as a minus, okay.
Okay.
And in this one, if I am applying this one, then my k theta would be the negative direction, this direction, okay. So in
Okay.
this my ky theta will also be, because I am taking ky theta in this direction, okay. So that would become positive, and that become as a ky theta, that will become a negative, so that become a negative. So these are positives, and that become negative. Now it is okay.
It is okay for time being, but uh, how can we? Is there any direction they have given, upward or downward?
In the direction they have given the
Okay, okay,
uy and u theta. So for the
okay,
resisting we need to take in the backside direction,
okay, okay. That
corresponding
means
to these
we have to
direction.
consider that directions
Yes,
also.
yes, yes, yes.
Okay.
This I have a doubt here. Like, can the diagonal matrix, the central, the diagonal, can it be negative?
It can be.
I think it will not be negative.
It cannot be negative, I think.
So our sign convention is different.
I think irrespective of sign convention, the
Yes,
diagonal,
it should be not, it should not be negative.
because when you apply along the direction of the, no, whatever conventions you are taking, that always has to be positive. Whether it is rotation or displacement, it will always be positive in that particular direction.
Okay,
The
so
effect on the other node can be positive or negative, but
yes, but that
on the
on that
same,
direction,
it has to be positive.
let me check k theta. If I am applying this one, like I am applying rotation in this direction. So yes, k theta, it would be in that direction over. No, okay, that would be what happen if I am applying theta in this direction, because our theta is given in this direction. In that, actually what happen, let me do redraw this. So what happen, our theta is applying in this direction, this one, downward, in the initially u theta, u theta in this direction, okay. There is some sign convention issue. So we are applying u theta in this direction, theta 1. So resisting force would be the k theta, theta this one. Okay. So if we apply k theta theta this one, then it is coming out to be same. You have any input? Someone has any input? How do we look into this k theta? Okay, we were taking the moment, and then if we do the apply into that direction, not that. So that that would be the same kb by 2, kb by 2, kb by 2, kb by 2, 2 kb by 2. So if I will take the moment about this at the center, so how much it would be coming out to be?
Can we say like when I apply in one direction, the other direction could be the displacements or stiffness, sorry, forces would be negative
In the
when I
other direction it can be negative or positive, but in the main direction it should be positive.
that's okay. When we apply a force in one direction, the other two direction can be negative.
Yes,
Then the main direction will be positive.
yes,
Can I say like that?
yes, that should be.
Yes, because in the lectures also, sir has said like we can apply force so that we will get a unit displacement in one that direction. The remaining direction which are opposite to the in other two coordinates, there will be a reverse direction to get zero displacement.
Okay, so we have the resisting force in this direction, or I think I have applied the correct force direction actually, but why it is coming to be negative? My k theta should be this, then that would be the k theta. Yes, then it would be okay. K theta in this, and the all the forces are applying, like the resisting forces. Those are like applying into which direction? Those are into the clockwise direction. So my k theta should be the,
Suppose if I'm not wrong, if you see in y direction, free body diagram. From that, I think we will get
Actually, my like with the resisting forces, my slab is rotating clockwise. The movement
okay,
are in the clockwise direction.
okay,
So I think my k theta should be in that direction. If like I am making some, let me go with the stick model. So that might help. That stick model, what happens if I apply a unit displacement in that direction? Okay, so that will be the resisting forces, and I am looking into that. That is the kx. Is it, is that the same direction I am looking? I think
yes, yes,
so. That would be the same direction. Fs would be the k theta theta would be the same direction.
yes,
So then it would become as a positive, and then
yes. We
that,
can say that was the negative. That is ky theta.
yes, and then it would become negative. Same
Yes,
thing would be like whatever we have done in the previous one, that was okay, but only due
yes.
to some sign convention problem we have some.
Okay, okay,
So that we can again, so that was the negative, 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 positive, positive. So that becomes negative, and in that it will be negative, and it would be positive. So that would be negative. So in this direction also that would be same. Like kxx would be the same. We are taking the reverse actually. So the kxx would be not this one. Whatever we have previously written, kxx, okay, and kyx and k theta x. The direction would be same.
okay, okay,
So that kxy all again have this direction. Then the kyy also have the same direction. So again everything. So in this also the k x theta and ky theta is this direction. Okay, now it's
okay.
clear. So the now we have the stiffness matrix. Now we can move with the mass matrix. So for the mass matrix, so in the mass matrix, in the first one I have applied x1 displacement ux displacement in this. So how much that would be the develop, that is a m in this direction. So how much the inertial force, that would be the m xx would be the m m would be m it would be there like the x double dot whatever it would be. So mx double dot in that direction. Same for the y direction. If I'm giving to this, then m would be in this direction. So myy would be the my double dot. Okay. Same for the torsional or rotational. If I am giving the rotation about this theta, so what is this I? Mb square plus d square by 12. Is it okay? So that b and d are same. So that become as a mb square by 6. So my mass matrix is that m is equal to m 0 0 0 m 0 0 0 mb square by 6. So now I can combine this equation. So if I will combine this equation, is it okay up to the mass matrix and the stiffness matrix?
Yes, yes,
So now we have the part B. We have to combine it with the like what is the question that we need to combine it with the ux uy in the x direction, y direction, and in the db direction. Okay. So the equation of motion, like in the x direction, what is the total? That is the u double dot total would be the u dot plus uz. Okay. So in the x direction, that would be the ux double dot t, uy double dot t, and u theta double dot t would be ux double dot uy double dot u theta double dot plus uz 0 0. Like my acceleration is applying only in the x direction.
So this UG will be double dot, no? That also will
Yeah,
be.
that will be double dot. That is the acceleration. So in the x direction it would be like that, and for the y direction also I can write in the if I my acceleration is like the ground motion is applied in the y direction. So how I will write it? That is the same. First one is the same. 0, ug double dot and 0. Is it okay? And for the db direction, then we can combine the equation so it won't be affect. For the db direction, it is for x direction, it is for y direction. For db direction, like let us just lab, this is a db, so you are applying a ug in db direction. Okay, so it would be have the component in the x and y. Okay, so how much component, because that is the same at a 45 degree, because the we have the square slab. So that is how much? U double dot z by root 2 and u double dot z by root 2. So in that case your u dot xt, u dot yt, u double dot theta t would become as a ux double dot uy double dot u theta plus u double dot z by root 2, u double dot z by root 2 and 0. Okay, so now we can combine our equation. Is there any doubt in the db? Is it okay? Okay, if not, then the in x direction, in x direction, what is my mass matrix? M 0 0 0 M 0 0 0 mb square by 6 plus u double dot x, u double dot y, u double dot theta plus stiffness matrix. We have the 6k 0 0 0 6k minus kb 0 minus kb and 3 kb square plus ux uy u theta is equal to minus mass matrix multiply with that factor, that one, that is the ug double dot 0 0, and the mass matrix is that m 0 0 0 m 0 mb square by 6. So you can write this minus m time 100 time ug double dot. Is it okay? Okay, so in the y,
But why is it only in the x and y direction? What is the difference actually?
what is that? Like
No, no.
only
You, UG double dot should be in both x direction and y direction.
No,
First and second
no,
row
in
it
the
should be.
no, because that my acceleration is applying only the x direction.
Why?
In the
For the
question it is given like
okay, okay, okay,
first we have the given the my acceleration is applying in the x direction. Second, it is given that in the y direction. Third is the db
okay, okay,
direction.
okay. Yeah, yeah,
So
that correct.
so for all the cases we have find out our vectors.
Yeah,
Now
yeah, correct. The assumption is like that actually. Yeah,
yes,
okay. So second, next one will come to y direction. Okay.
yes, in the y
Yeah. Okay,
direction
sir. Understood.
our mass matrix would remain same. That will be stiffness matrix also remain same, like that. Plus that would be mass matrix, and over this one becomes as a 0 ug double dot 0. So that becomes as a minus m 010 ug double dot in y direction. And in db direction, if my earthquake is in the db direction, so what happen, everything remains same. That would be mass matrix, and that would be the uz double dot by square root 2, same by square root to 0. So my influence vector is minus m 1 by root 2 1 by root 2 0 into ug double. So I have the influence vector for the in x direction. I have the influence vector L is what 1 0 0. In y direction I have L is 0 1 0, and in db direction I have influence vector 1 by root 2 1 by root 2 0. So these are the influence vector in all three cases. So that is being used in the like in the analysis when we do the finding out the response corresponding to any ground motion or something else. At that time those influence vector will be utilized. So any doubt in this question? No, because we have some little bit confusion in the sign convention. So I think it now it would be clear, it will be clear everyone. So now we have the two more questions. So we will try to finish it. If not, then the solution of that question will be uploaded on the pdf. Okay, so first let us do this the question one. So in this, we need to determine the flexibility matrix for the two element frame of the figure. For both the element, the flexural stiffness is the EI. Axial deformation are to be neglected. The frame is massless with the lumped mass at the two node as shown. So we need to determine the flexibility matrix. If we are able to find out the flexibility matrix, then we can find out the stiffness matrix as the inverse. Because sometimes it is easier to get the flexibility matrix rather than finding out the stiffness matrix. So in the most of the complex cases where the degree of freedoms are more, then we go for the flexibility matrix. So it would be easier to find out the uh, then we can calculate the stiffness matrix by using the flexibility. Okay, so we have the degree of freedom u1 u2. So in the flexibility matrix like I and j, let us suppose, so we have the component f11 f12, okay, f21 f22. So can you tell me what is the meaning of ij? I is for what and j for what in the flexibility matrix? Anyone?
I should be displacement in the I direction.
Yes, I like if I apply a unit load,
Unit displacement. Yes.
unit not the unit displacement. If I apply the unit load in the jth direction, then
Correct.
the displacement in the I direction corresponding to that.
No, sir. Can we tell like make a unit displacement in I and the corresponding force in J.
No, 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 no,
No, no, that
no.
is
That is the
stiffness.
stiffness.
Okay.
For the stiffness, we apply the unit displacement, then we find out the force. F is equal to kx. And for the flexibility matrix, we apply the load and then we will find out the displacement.
Okay.
So J is the deflection, and I is the, like, I we apply like the deflection in the J direction due to the unit load applied in the I direction. That's all. Here only unit load we are talking. So Fij meaning, like, represent the deflection deflection in jth direction due to unit load applied in ith direction. Okay.
No, I think deflection in ith direction due to unit load applied at jth direction.
Are you saying like deflection, like deflection is the ith direction?
Yes, yes,
Yes,
correct.
sir. That's what I'm also thinking. I'm also thinking like that actually.
Deflection,
Long back.
uh, left.
Because flexibility about deflection. No? So when we are talking about I is the displacement actually.
Yes,
Let,
displacement at ith direction due to unit load at
At J.
jth direction, j direction.
yes, that would be reverse. So that would be the ith and that would be the jth. Okay. So now let me apply a unit load to that u1 direction. So if that is a frame and I am applying a unit load, p1 is equal to 1 something, so I need to determine the deflection in the jth direction. So what is the displacement at this point, at this u1 and at u2 due to this p1, I need to determine. So if I apply p1 is equal to 1, so u1 in that this direction, so that is the how much deflection is that, that is the transferring to whatever the load on this, so that is the 1 kilonewton in this unit load, so that deflection is that,
3 L by L cube.
that will be the, so the uh, deflection is the pl cube over 3I. Okay.
Okay.
So my flexibility is what, for the,
Where P equal to 1 L cube by 3A.
so that is the l cube by
3A.
3a. So that is my f11. So due to this, how much deflection I am getting u2? Can you give me that?
0.
No, not zero. When I apply a force through this one, so in this I have the rotation at this point as well, theta.
Okay.
So how much that theta? That is the pl square by 2a, pl square by 2e.
Okay.
So due to that theta, how much that will go downward linearly? That displacement u2 is l time theta,
Okay. Okay.
so that will become as a pl cube over 2ei. Okay. So my,
If suppose that u2 is in theta direction, for example, u1 is okay. If u2 is actually we are showing u2 is downward, right?
yes,
if suppose u2 is in theta direction,
U2 in
what
which direction?
theta direction, nothing but rotation,
Yes, then rotation. Yes.
then that deflection will be PL square by 2A, right?
Then it would be same. It won't change deflection, I think. No.
Theta direction. I am asking here we are giving u1, u2 x and y direction, right?
Yes, yes.
If z direction, I am asking z direction, nothing but theta direction.
Okay.
In that case, that f21 will be PL square by 2A, right?
Yeah, whatever it is. Yes, that will be same.
Okay.
So that F21 is the PLQY, not the PLQY 2EIs. Okay. Now I am applying unit load in U2 direction. So in that, if I am applying this one P2, so how much is this? How it will deflect? Like that, something.
Yes.
So due to this P2, I have a bending moment at this point also. P time L, MB. Okay. So first I need to find out the U2 and the U1. So first let me find out the U1. How much displacement is this? So due to this bending moment, how much my load will be there? Like this one, and I have applied the bending moment MB. So how much deflection is there at this point?
ML square by 2A, right?
So that would be the ml square by 2ei.
2A.
So that is the ml, not ml square by 2ei, and m is what, pl. So p would be 1. So that is a l cube over 2ei. Okay. And in the p2, how much deflection is that? One is that lpl cube over 3i. Okay. And one additional deflection, whatever rotation is there, due to there is a deflection, theta time l. And what is the theta? If I have the bending moment mb is here, what is the theta? That theta, how much theta is that? Ml by ei, or how much? Ml over ei, theta. So that is the pl square over ei. So my u2 or f22 becomes as a l cube over 3ei plus l square ei time l. So u2 becomes, f22 becomes l cube over 3i plus l cube over ei. So that becomes as a 4l cube over 3i. Is it okay? Any doubt? Anyone has any doubt in this?
I have a doubt. That means in the question, it is a massless column, right?
Yes,
That means
yes.
if it is rigid means we don't have any zero, right? That F12, F21. In that case,
Which one?
so here you are if you if one if when we calculating this F21,
Yes,
we are considering theta into L, right?
yes,
If I want to actually that suppose EI is rigid, for example, in beam,
yes. If you are considering the rigid beam, yes.
in that case that will be zero, right?
Yeah, in
That,
that case, that would be that deflection won't be there. Like only
uh,
the column, whatever the deflection, that the PL cube over 3i would not be there, actually.
yes, yes, yeah. That's why I'm confusing it. Okay,
No, it here is nothing like that rigid. only that the columns are massless and we have the masses are lumped at that point.
Yes, yes. Okay.
So my flexibility matrix will become as a
Had that been the case, now they would not have defined the problem like this L shape. They would have simply given a simple cantilever.
simple, yes. In that case they do not need to define that if
Yeah,
that is
L
the
shape.
rigid. Yes,
Only, yeah, only they can put a simple cantilever. That's all.
yes. So my stiffness flexibility matrix become as a L cube over 3ei, L cube over 2ei, L cube over 2ei, and 4L cube over 3ei. So that becomes L cube over 6ei 2338. So now you can, like, only the flexibility matrix is asked. So the stiffness would be the inverse of this matrix. This one. In the last problem, we have same kind of things. In this also we need to develop the flexibility matrix, and then after that we need to do some like the model, like the frequencies are given. So using those things, that is the easier. So in that case also the flexibility matrix is determined, need to be determined. So in that case, like first you will apply the u1, same kind of case is there. So you will apply a unit load p is equal to 1 at this point. So when you apply a p is equal to 1 at this point, how much your deflection at that point, so we need to determine. So if I apply a in this, let us suppose a unit load in this direction 1 kilonewton, so how much deflection at that point, can you tell me?
PL cube by 48 EA.
Yes, so f11 would be the L cube over 48 ei. Is it okay? And what would be the f21 deflection? If here, like, that would be linearly. If that is the PL cube over 48 ei, then that would be the PL cube over 96 ei, half of that. Is it okay?
Okay. If it is linear, it's
That would be
okay.
linear because, like, there is nothing movement because that is the hinge at that point. So how
Okay.
much, whatever force I am applying it here, so that would be the, like, whatever displacement is here, that would be the half linearly variation.
Okay.
So
Okay.
that would be the 1 by 2 of L cube over 48 ei. So that will be the L cube over 96 ei. Now I am applying display load at u2. So if I apply it u2, this one, okay. So in this also, if I am applying this one as the one unit load, how much load it will be applied at here? 1 by 2. At that point, how much load it would be? 1 by 2, half of the unit load. Is it okay or not?
I didn't get.
Like,
Should it not be two?
no, there is a reaction. Like, I have a beam on this, and I have a this one, this beam also. If I am applying a unit load of 1 kilonewton is this, okay. So how much reaction it would be here at both the point?
Okay. Half. Half. Okay.
Half. And due to that, how much deflection it would be there? That would be the deflection would be the L cube over 96 ei, okay.
Okay. Okay.
So that becomes f12 becomes as a L cube over 96 ei. Is it okay?
Okay.
Now after applying this, how much deflection in this, can you give me this? How much f22?
That is also PL cube by 48 EA,
Yes, and
but L is different, right?
that would be the Actually, what happened, that would be the, like, that much is there, and then it would be like that. So that would be whatever deflection is that, it is the PL cube over 48 EI. Okay.
Here L is same, right?
Yes, L is same for both them, both the
For
cases.
example, L1 and L2, for example.
Yes, then what is the issue? You will take the whatever the numerical value you have, or in terms of the L1 L2 you can take it.
No, no, there F1 to F21 can, or F1
how
and F2.
how it would be changed? Like length, it will be in terms of the length, it will vary like that. I don't think so, like if the length is different, then there is any difference. Like it will terms in the, like whatever ratio is there. So first let me get the F22. so
Okay, okay.
so in that, the first is the, we have the applied 1 kilonewton, so there is a PL cube over 48 EI, one is that, and there is a deflection is here. What was that? That was the L cube over 96 EI. So the half of this will be there, PL cube over 96 EI time 1 by 2. Did you get it?
Yes,
So your F22 will be L cube over 48 EI plus L cube over, that would be the 96 times 2 EI. So that is coming out to be 5 by 192 L cube over EI. So this, your flexibility matrix, when you combine it, it will become like that: L cube over 48 EI, L cube over 96 EI, L cube over 96 EI, and that is a 5 by 192 L cube over EI. So that becomes as a L cube over 192 EI times 4225. Yes, what was your doubt now?
in terms of L1 and L2, I want
Yes,
to know.
let us suppose you have the, uh, this one is the L1, and this is L2.
Yes.
Yes, then what would be the issue now? Now tell me.
Then F11 will be L2 cube by 3 area. L2 cube by 48 EA.
Your F11 would be the L cube over 48 L2. That would be the L2. Uh, that would be L2 now. So
Ah,
that would be the L2 cube over 48 here. Yes.
okay. Then F21.
The F21 would be the what? Like whatever you are, like that would be the also, like if I have the L1 is 10 or 20, or L2 is however 30. So it's the mid, that is half of this directly.
Half of means here. Can you please note down with your pen that F11 will be L1 L2 cube by 48 EA.
Yes. So go, let it be go with the L1. So your delta 1, delta in the 04 beam will be the L2 cube over
Ah,
48 EI. Okay.
okay.
So now
Yes.
delta 8 2 in the 2 3 beam, 1 3 beam, how much it would be? That would be the vary with the linearly. So that would be
Yes.
the how much? That would be the, uh, this divided by the, like L2 cube divide 48 EI, divide by or multiply with the L1 by 2, multiply with the, like, that deflection, that linearly, divide by the, like that will be divide by the L1 and then multiply with the L1 by 2. That will be same. I don't think like there would be any change in the F11 and F21. No change would be there. That would be same as the L2 cube over 96 EI. That won't
Okay.
be L1,
Okay.
because
Yeah.
whatever is there, that will be half.
Okay. Then can you Delta 1 2. Can you write delta 1 2?
Okay, then our delta 1 2. So in the delta 1 2, what will happening? Like I'm applying here 1, so there is some reaction force 1 by 2 because it is at the center. Okay,
Okay.
so at the center, then it would be the in terms of the again L2 cube over 96 EI.
Okay.
That thing can be different, like if you have confusion, because it is at the center. Like let us suppose your 2 is not a center, like it can
Okay.
be like 4 in like some ratio 2 or 4. It's something
Okay.
like that, but the that coefficient, multiplication coefficient would change, but that L2 term would remain the same. In that last one, that would be changed. In the last one, what will happen, that will ever become L2, that term become L2. In the F22, that become L2 and that become L1. That will
Yes. Yes. Okay. That's okay.
that will no
It is fine.
that will be the L1 and that will be L2, like reverse. In that will
Yes.
be happen in the last F22.
Okay. Okay.
Is it clear now?
If, for now, I have cleared now that
No, if you
you
have any
actually.
doubt, you can still ask. No problem.
No, no, no doubt, no doubt.
Okay. So now you have the flexibility matrix. So you can like the inverse to find out the K matrix. You need to do the inverse of this. So when you do the inverse of this, I am getting this. Let me write it directly. So that is coming out to be 192 EI over 16 L cube times 5 minus 2 minus 2 4. Okay, K is there. So now they have given you the EI value as at 2400 kilonewton meter square. They have given the length 6 meter. So if you put this, your K will become as a 4 into 10 raised to power 5 by 3 into 5 minus 2 minus 2 4 Newton per meter. This is your this one. And for the mass matrix is simple because at that point, how much? At that point, it is a one is the mass is there, which is W is equal to 10 kilonewton, and mx is given as a 4.5 kg per gram. So at the end, how much at the V1 and V2 we need to find out. So so for this beam, it is like we need to find out the mass distribution. So at the end, it would be the ml by a degree of freedom 2. That would be the ml by 2. So along with that, we have the mass distribution in this also. So we need to take care of this. So we have the mass is 4.5 kilogram per meter in both this. This is also 4.5 kilogram per meter. So in that, this is the V1, this is the V2. So in this V1, how much that mass would be the that 4 point time 6. Okay, so how much at this V1, that partition, that would be by 2, and at the center, that is the one thing, that is the one mass. And in this, how much mass at the center? So for the UDL, how much it would be there? So we need to determine the mass distribution. Like let us suppose that is the mass given to us, and we are applying it V1 and V2. So this one, how much? That would be the ml by 2. Can we determine the mass distribution?
Means,
Like we have given the like the mass as a mx per meter, kilogram per meter, and along with that additionally we have the w weight. So
okay,
for the sake of w is like let us rest is, so we have the mx.
okay.
Okay, in the question itself it is given, so we do not need to go there. In the question it is said that assuming that the distribution of the mass at the each beam to be lumped at the half of at the center and the 1 by 4 at the each end. Okay, so we do not need to do anything. So in this, how much at the center it is, how much ml by 4, and at the support it is ml by 2. At the half of ml by 2 and at the support it is ml by 4 for the first this beam, and for this one also at the center it is ml by 2 and at the support it is ml by 4. Is it okay? So how much mass at this point? This would be total. So at the m11 would be the ml by 2 plus ml by 4, and m22 would be the ml by 2. Okay, plus that thing also, that the weight w is also added. Is it okay now?
Yes, yes. Okay, okay.
So now using that over m11 is that ml by 2 plus ml by 4, that will be the 3 by 4 ml, and m22 is that ml by 2 plus w. So 3 by 4 into m is given to us a 4.5 times 6, so that is 20.25 kg, and in this it is 1 by 2, 4.5 times 6 plus weight is how much, 10 kilonewton. So that is the converted to kilogram, so that is coming out to 1032.86 kilogram. So now you have the mass matrix 20.25, 1032.86 in kg, and you have the stiffness matrix. We have calculated k is equal to 5 minus 2 minus 2 4 multiplied with the 4 into 10 raised to power 410 raised to power by 3 Newton per meter. So now you can solve this for eigenvalue and vector. So for eigenvalue and vector, if you solve this, k minus lambda m is equal to 0, you will get lambda 1 is equal to 4117.79, and lambda 2 is 33026.44. Using that, your omega 1 is coming out to be 20.3 radian per second, and omega t is your 181.73 radian per second. Okay, so using that, for lambda 1 you can find out the mode shape. So it, in this it will be coming out to be 511 is coming out to as a phi is 0.405 and phi 21 is 1. And for lambda 2, your mode shape is coming out to be 125 and 1. So your model vector is that 0.405, 1, 125, 1. Like the rest calculation you can do, or that will be uploaded on that site, that the drive folder. So you can do that. Any doubt in the all the six problems now? Any?
No doubt.
So that sign convention is clear now. That the
Yes, yes. Clear.
actually that time also I have written, but that I don't know how I was confused. But at the later I will clear that.
Okay, okay. No problem.
So if you have any doubt in the any questions, you can ask me here or on the Google form also, like the doubt session. That is updated or not? That your marks,
Yes, yes, sir. Updated,
those marks
updated.
are updated. Okay.
Yes, sir. Updated, sir. Thank you, sir.
So any suggestion, any feedback, because we have remaining around 4 session or also. So is there any improvement or is it whatever it is going is okay?
Yes, for me, it's okay, sir. I'm very
Very
much.
nice, sir. No,
Yes,
no problem.
agree.
Very nice, actually.
Okay, that is a good for me also. Sometime discussion because sometime I may also wrong.
Yeah.
So that happens.
Mm.
So
Now,
if I
now I am able to uh, understand the dynamics. Actually, I am new to dynamics actually,
okay.
but I'm very much getting interested towards these sessions and lectures.
Okay.
I think if it's possible, more number of problems. No, not in problem solving session. In material wise, if you give any more problems.
Okay, if I will find, then I can upload more number of problems because in the session I can cover, because now we have the long problems in the next
Yes.
3 sessions also. So
Yes,
today,
yes. I'm also asking in the material wise
yeah,
only.
material wise,
If
that
you
can
can
be.
upload more problems, it's okay.
Yeah, in that if we can do with the time, with the 4 to 5 problems are enough. But last, like only the calculation part you can do yourself, and that I will upload on the material. So that's I am skipping. So that's only the conceptual parts is main.
Okay, okay, sir.
So that's all.
Sir, is there any impact on because of the closely spaced modes?
In the closely spaced mode, what like
No, in problem solving, I have not seen any problem with closely spaced modes.
that will be, that thing will be we discuss in the next week. That come into that.
Okay, okay,
Here, like
okay, okay,
here, our main purpose was to like to generate or the made the governing differential equations, not the mode
okay,
shape and that we will
okay,
discuss in the next part, I think.
okay, sir. Okay.
Okay, sir. Thank you very
Okay.
much.
Okay.
Thank
Thank
you
you,
very much, sir.
everyone.
Thanks. Thanks. Bye.
Now you can leave.